Hey, this is Horner, and this is the second part of electrostatics, what you need to know in order to pass the AP Physics 1 test. And we're going to talk about charges. So the current model of subatomic structure is called the Standard Model. And they started looking at this in the 60s, and we look at different types of forces. So there's something called a strong force, electromagnetic, and a weak force. But we really haven't figured out what the gravitational force is. So why are we talking about this, and how does it go along with electrostatics? Well, what we've been able to do is look at protons, and we know that protons are not the smallest things that we can break down into, but an electron is. And in order to think about matter, what we've done is we've classified matter into two different types. One type is called a hadron, and the other one's called a lepton. A lepton includes our electrons. So here's our electron, and you'll see that there's a table of these different things over on the right side. So leptons are electrons. We also have things called muons and tau, neutrinos, all kinds of weird things like that. But we're not worried about anything other than just our electrons. So an electron is a lepton, and it has a charge of -1. An hadron is a little bit different. A hadron will include things that will make up a proton. So for example, we have baryons and mesons, and then we have three quarks and something called a quark and an antiquark. We don't really need to know any of this other than there are three quarks. And physicists are kind of weird. They name these quarks things like up, charm, top, down, strange, and bottom. And the only ones that we're really going to worry about, remember, we're going to talk about leptons that are electrons, and then we're going to worry about the up and the down quark. And we said that everything has a charge. In fact, if we look at the up quark, we notice it has a 2/3 of an elementary charge, and then a down quark is -1/3 of an elementary charge. So when we look at protons, protons are actually made up of something where we have two up quarks, so two up quarks and one down quark. Now why are they made up of two up and one down? It's because we know protons have an overall charge of +1. So an up quark is +2/3 minus a down quark, which is -1/3. If you add these up, we get 2 plus 2 is 4/3 minus 1 would be equal to 3/3, +3/3, and that would be equal to a +1 charge. So because we have two up and one down quark that make up a proton, that proton has a +1 charge. So we're going to use that in this next problem. So let's look at this problem. It says a neutron is composed of an up and down quarks. How many of each type are needed to make a neutron? So the first thing we have to think about a neutron. Oh, that's right. A neutron is neutral. It has no charge. And when we look at up and down quarks, we know that up quarks are equal to 2/3 positive, and down quarks are equal to -1/3. So we've got three altogether. So what combination of these would make 0? Well, you're right. If we take 2/3 positive, add that to -1/3, and add that to a -1/3, this would be 2/3 plus -2/3, and that would equal 0. So we said a proton was two up and one down, and that made a +1 charge. If I have one up and two down quarks, that equals no charge. So our answer here is up, down, down. So this is the new physics. Well, it is since the 60s, I guess. So it's been around for quite a while, but we don't usually talk about it much. But they want you just to understand that the charge here for a proton is +1 because you are using smaller charges from quarks, which are up, up, down, and then for a neutron, it would be up, down, down. And that's all they really wanted you to know.